Acceleration is the rate of change of velocity, or else we can term it as the velocity change occurring per unit time. Simply, that is the change in velocity happening for every second. When an object is moving, it may be either increasing the velocity or decreasing the velocity. That means it's totally different, opposite from uniform velocity. In uniform velocity, the object is moving at the same speed, same velocity, uniform. But in acceleration, the speed, the velocity increases. Usually the word the speed we use to denote as the rate of change of distance. Velocity is what we are using for the rate of change of displacement. So along with displacement comes velocity. So velocity is connected with acceleration. So the link should be very clear, right? So again, acceleration, the rate of change of velocity. So velocity change we are dividing by the time taken. Accordingly, we find out the acceleration. So if it is increasing velocity, that is termed acceleration. If the velocity is decreasing, that is called deceleration. So as far as a positive answer, a plus answer, a plus numerical value given, that's acceleration. When the numerical value becomes minus, a negative acceleration, that is called a deceleration. So whatever, find out the acceleration, there should be minimum two velocities: starting velocity and ending velocity, initial velocity, final velocity. So to take the velocity change and dividing by the time, we are using a simple formula which is always considered focused within the questions. So how do we find out the acceleration? Acceleration is equal to, simple A, it's equal to velocity change dividing by the time. Velocity change dividing by the time taken. So the velocity change, I can term it as starting velocity, we term as u, ending velocity, final velocity, we term it as v. So to obtain the velocity change, we have to take it as v minus u, and we are dividing by t, that is t. So acceleration is equal to final minus initial velocity dividing by the time taken. So the velocities we are measuring by ms minus 1 meters per second and dividing by the time taken, that is also seconds. So accordingly, acceleration is measured as ms minus 2 meters per square second. All right. So let's get into some questions. Let's say an object is started from rest. Starting velocity, rest means it's zero velocity. And it obtains a velocity of 50 ms minus 1. So an object starting from rest acquires a velocity of 50 ms minus 1. Timing would be also given. Let's say the time is 10 seconds. So first question, starting velocity 0, final velocity 50 ms minus 1, time taken 10 seconds. So how do we find out the acceleration? So this is the formula that we are applying here. A equals v minus u over t. Final velocity is 50 minus 0 dividing by the time taken, it's 10 seconds. So 50 minus 0, 50 over 10, it is 5. And since it is acceleration, it should be ms minus 2. So acceleration equal 5 ms minus 2. Acceleration equals 5 ms minus 2. So this is the answer for first question. Like, let's take another question, number 2. I'll take the question number 2. Same question, I'm going to take it up and down. Earlier we took it as starting from rest, ending at 50. Now let's say it is starting from 50 ms minus 1, ending at 0. Ending at 0. And the time taken, I'm giving the same timing, it is 10 seconds. Now how am I finding out? I have to start up with the same formula, A equals v minus u over t. But now the final velocity is a 0 value, initial velocity is a non-zero value. Final velocity is 0 minus initial velocity is 50 dividing by 10. Now you can see the difference is minus 50. So minus 50 over 10, answer would be a minus value, which is 5 ms minus 2 with minus 5 ms minus 2. So this answer is not an acceleration, it is a negative acceleration, which you term as deceleration. So that's the difference between the acceleration and deceleration. Now, is it always the acceleration and deceleration you are finding out? Is it always starting from rest or ending at rest? Is it? No, it is not like. It's not like. It is not always there should be a non-zero and a 0. There can be both a non-zero value. Both non-zero value. Both zero means it is not accelerating or decelerating. It is moving at the same velocity. So either one is zero, the other one is non-zero, or else both of them are non-zero values. For an example, let me take something like this. An object is moving, right? Starting velocity is 10 ms minus 1. Starting velocity is 10 ms minus 1. After some time, let me take it as 20 seconds. The same object after 20 seconds, it's obtaining a velocity of 70 ms minus 1 after 20 seconds. Now, how do I find out the acceleration? Equation is same, v minus u over t. V minus u over t. Final velocity is 7. Initial velocity is 10. So, dividing by time taken, 20. 70 minus 10, 60. 60 over 20 is 3. So, the acceleration here, in this case, is 3 ms minus. So, related to acceleration, the fundamental formula, fundamental equation we are using, these are the three ways the questions could be asked.